Right, so I think this may be one of what Gita referred to yesterday as a dense presentation. It's about a piece of infrastructure that, how old is Conga now? It must be 6 or 7 years.
Yeah.
That Bjørn is the author of. It's, I think, gradually becoming more and more important. It's what provides access to the internet if you want to, or in your intranet, if you have a service that you want to provide and make available to other computers, or you want to rate a web server or consume a web server, web services, Conga is the tool that we recommend. How many people are using Conga today? Okay, so that's a fair number. The rest of you can maybe go to sleep for the next 20 minutes. So I said the web stack of the future, which is perhaps a slightly pretentious... do we have a clicker?
There was one up here.
There's one up here. Title for this. I mean, there's this OSI model with 7 layers starting down at the Ethernet cards or the token ring. If you go back a bit, then there's something called IP, Internet Protocol. And now we're getting into the layers that we sort of start to understand. There's TCP, which is a layer built on top of IP, where the underlying operating system will allow you to send a message to some other computer. You give it an address and a port number. It'll send it, it'll verify that it gets there, that it's been delivered. And then we have something that we're not using yet, but the next version of Conga will give access to UDP, which is a datagram protocol, which you would typically use if you wanted to say, can somebody tell me the DNS address of something? And you hope that you broadcast that, and you hope that a DNS server somewhere is going to respond to it, or NetBIOS. Or if you're doing gaming, and you want to send out a whole bunch of broadcast messages to other people on the network about your current location or whether you fired your gun, and you don't really care whether they get it, because you're going to be sending out another message a millisecond later. And then we have this tool called Conga and your APL application on top of that. So if we just focus a little bit on that and what you might be using it for. Oops, thing has switched itself off. We don't have, we can only use the laser pointer, sorry. Okay, so you have the TCP layer that we looked at, and then you will typically have protocols like HTTP, hypertext transfer protocol, and then on top of that you'll have higher level application protocols like HTML for web content, SOAP or REST if you're providing services, and then eventually you'll have an application sitting on the top of that. And at the moment, Conga looks after the transmission, but then you'd basically be writing all the rest of it in APL, and we've been working on various tools to do that. What we're transitioning towards with Conga 3.0, or the web stack of the future as we think of it, we're going to extend Conga so that it's going to take care of the HTTP part of this, so that you don't have to worry about, there's one more layer of the protocol that we can take out, and then we provide tools like MyServer to look after the HTML, the SOAP, the REST, etc. And your APL application just becomes this, your business logic sitting up there somewhere. So that's the setting the scene. The Conga features that are coming into version 3, I think it's probably the biggest release we've had for a very long time.
Very, very long time, yes.
It collects customer feedback and requests. There are some customers who've had some of these features and been testing them for a couple of years, but we're now rolling them out. And the important ones are, the two first ones, actually new threading model is a bit mysterious. The first two are really about scalability. So we have customers who are using this with 40,000 simultaneous users, and they found a few things to complain about that Bjørn has been working on. There's things to do with security and various other things that are going to make life easier for you as application programmers. There's a slide on each one of those, so I'll just move on. So the optional threading model, traditionally you would run an APL thread which would listen for activity on the TCP socket, and then whether they were connections or incoming data and so on, you'd be running this one loop which would handle all of that. And then you might spin off a thread to handle the request, but typically that would run for a bit and then terminate, and you'd have this one main thread doing all the work. We found that there were some people who wanted to establish a long-running connection between a client and some piece of the application on the server side, where it made more sense when you got a connection to spin off a new thread, and that thread would then listen on that particular connection and handle all the communications. So it's typically something you would do if you have a long-running stateful session connection with some client. And this new feature where you can say when you create a server that you want only connections allows you to, each time you get a connection, spin off a new thread and listen for that. So it simplifies that programming model if it works for you. There's some significant work that's been done on scalability for very large applications. This really applies to the other mode of operation where you've got one thread listening for everything. In the past, Conga was less optimized for high throughput, and it allowed the server side to do sort of querying on little subsets of the tree of connections that you might have. But people working with very large applications would say they would prefer just to have the data, the incoming transmissions just delivered in the FIFO order, and not do any searching or filtering. And taking out that complexity from the Conga layer just means you can have very much higher throughput. It's less flexible, but gives you much higher throughput for server applications. Running without security features, you might say, well, why would we be doing that? Surely everybody wants to be moving in the direction of using security. But it's the Secure Socket library, or GNU TLS, I think it is we're using, is about adds another couple of megabytes. And in some applications, if you really don't want to use the security, we are now dynamically loading that, so you can leave it out. It was also a cause of some errors in deploying Conga, where people would leave that library out, or they'd have the wrong version of it, and you simply couldn't start Conga. So now, if we don't have the security library, it'll just fire up, and if you don't use secure sockets, you will be fine. One of the things that APL servers often get called upon to do is simply serve up static HTML. So my server, for example, although it has this scripting language where you can generate dynamic content, it's also going to be serving up a large quantity of images, CSS files, and pieces of static HTML and so on. So we've added a feature where when you're sending a response back, if you're a server and you're sending a response back to a client, you can give it some HTML. So we've built something here called answer, which contains a little bit of HTML header information, status information, and so on. But then as a second element to this array, you can just give it a file name. So if you pass a nested array of some HTML, some HTTP, I guess to be strict, and a file name, then Bjørn's C code will take care of chunking and blocking that file and sending it in reasonable pieces down to the client side. Whereas before you would have to write your own loop, you'd have to loop, read a reasonable amount of data at a time, and then move on. Perhaps the most significant enhancement for people who are writing web servers is that Bjørn has added this HTTP protocol support to Conga itself. So where before you would have to receive a stream of data coming in, broken up in chunks, into APL, search for the beginning and end of the headers, information about how much data there might be in content length, whether it was chunked, and so on, and do lots of string searches and code of a style that APL isn't perhaps the best language in the world to do. Bjørn is now collecting all that information, and on the server side, as an APL server, you just get one of these messages each. As soon as there's a complete HTTP header, you get that. When there's a body, you get that. If you're in chunked mode, you'll get little flags to tell you that, here's another chunk. And even a trailer. I've never seen an HTTP trailer, but apparently they exist.
That is actually just a header that is coming after some chunks.
Okay. And this, you can't read this at all, but this is just a diff between some server code handling.
That is the HTTP CMD from the samples workspace, where I've converted it from using the old way to using the HTTP protocol. So a lot of the code will kind of get obsolete, and you can throw that out.
Right, so I was incorrect. I said this was server code. This is client code.
That is actually client code,
yeah. So this is a piece of APL code that's distributed HTTP command, and it allows you to, from APL, make an HTTP request to a server. So if you want to go to Dyalog16 and read what's on our front page, you could use this function and give it an address. And before there was all kinds of code here. We zoom in on it a little bit. You can see we're searching for the beginning of chunks and lengths and was it the last block and various stuff. With the new HTTP support in Conga, that code is cut down to just actually dealing with the various parts of the HTTP as it comes in. Right. The next thing we're trying to do is add some wrappers for typical use cases. So the building of a server on top of a Conga server object or a client. There are, in the previous distributed workspace, there are some examples of how to do that. But we're experimenting now with using object orientation to make it much simpler to set up a server that's just going to respond to HTML events coming in. So if you, for example, had an application which
This is just running command mode.
Which could reverse the data, incoming data. So it listens on the socket, it receives an APL array, reverses it, and sends it back. So this is your business logic here. Then all you have to do now is to write a class where you have that function called onReceive. And then there's a class there's a class factory where you can say, give me a server, listen on this port, and use the myServiceHandler class to handle any incoming requests. And then if you have an onReceive function, it will override what's in the base class. So it's very much easier now than it was before. Before you had to sort of write your own. We had a sample, which was a loop, I guess about 40, 50 lines of code. And then you could go and insert your logic in the middle there. Now you just create an instance of an object with a suitable class. And on the client side, this replaces, I guess, the HTTP command function.
No, this is command mode.
Oh, okay, this is in command mode. So for those of you who don't know Conga, it operates, well, it used to operate in two modes, basically command mode, where you could send an APL array, and the assumption was there was an APL server at the other end that would receive that and get it back. Or you could be in raw mode, where you were sending raw text or bytes. And this is assuming that you're using the command mode, of course, because the server we're dealing with here is command mode. So now in Conga 3.0, there's going to be a third style of connection, which is the HTTP. So you declare a connection to be an HTTP connection, and then the system knows that you're sending complete. Right. So MultiRoute. One of the things we found as the use of Conga grows, is something that I think is very common when you build a tool. You imagine it's going to be used for some purpose, and then you start using a tool where somebody like Kai or Phil has decided they also want to use Conga to talk to their source code management system. And suddenly you have a conflict between the TCP resources that you're using in your application and the source code management system. And I think Kai's had to jump through hoops backwards to try and isolate. He might actually want to use a different version of Conga sometimes. We can't, well, he can still load two DLLs. But basically what we've tried to do now is to allow you to, so the application can say, well, I'd like to initialize a route without giving it a name. You then get an object back from this factory, I guess we'd call it, where you can start making servers and so on. And if you use the Conga API call to say, well, which names do I have defined? It'll say, well, you've got this server 0, which is the default name that was created. And then Kai, if he wanted to, or Phil, if they wanted to initialize their source code management system, they could say, well, I'd also like to use the class factory, but I'm going to give it an ID of CRD and get a new namespace back. And then you have these two namespaces, which are actually using the same copy of the DLL. The DLL is only loaded once, but you have isolation between the uses. So this one says, well, what names have I got defined? It's also got one called SRV000, but it's not the same one as up here. So you don't get name conflicts. If the source code management system says, I'd like to, I don't know what state I've ended up in, I'd like to close all my connections, it's not also going to close all the connections that the application is using. The UDP support, I just got this slide half an hour ago. I didn't have time to look at it. But basically, this is really Thomas. We're doing this for Thomas.
And he's not here.
He's not here to appreciate it. He needs this for his gaming servers and stuff. Yeah. So he can do this broadcasting of where all the players in his multiplayer game are.
What's UDP? User Datagram Protocol.
Protocol, yes. Yeah. Datagrams. So you're just broadcasting messages without necessarily a specific address and with no guarantee that they're going to be delivered. So it's something that's typically used by games and things that are broadcasting information. And
also other practical protocols as DNS and SNMP, and there's a lot of application for UDP.
Yeah. And then the final piece before we hand over to, or the introduction to handing over to Gil, is that we're adding support for WebSockets. WebSockets, I mean, typically when you use HTTP, you have a browser, it sends a request, the server sends an answer back. But modern applications like the one that Michael was showing yesterday, you really want to be able to have immediate response. If you're searching in Google Maps or Google Search, you get autocomplete. That's because every keystroke that you make is being sent to Google, and they're doing predictive stuff based on the keystrokes and responding immediately to what you're typing. And WebSockets is a way of taking a connection and upgrading it to something where both parties can be sending data. You don't have this asynchronous, first I send, then I get an answer back. And in addition to allowing, interactive stuff like that, it's also what's going to be the basis for the two-way data binding in my server, so that if a variable changes in the server workspace, the server can immediately transmit the change down to the JavaScript code running in the browser, and vice versa. You don't have to be waiting for a send and receive. And this is done through some quite simple interactions. If you're a client and you have a connection, you set the WebSocket upgrade property, and a little bit later, after Bjørn has done the negotiation with the server, you'll get a web service response. On the server side, if you have a client, which might be an APL program, but might also just be a web browser, you'll get a web service upgrade request. And if you're willing to upgrade, you set the web service accept property, or you just set auto mode, and you just get an event that says your connection has been upgraded. And after that, you start getting some WSF events. Yeah. I'm not sure what the F stands for.
You could actually get both WSC and WSF commands, and that is for continuation and final.
Continuation and final, yeah. Okay. So there you go. So Gil has been playing with these WebSockets, both really before Bjørn got started and now helping us with the design of this. And he has a little sample application that he's going to show us in the last 8 or 9 minutes, Gil, is what you have. Is that going to be enough? Are you there?
I am here. And yes, that should be enough.
How do I make you the presenter?
You should see my screen already. You might need to bring it up.
I just make it full screen.
Can you hear me okay?
Yes, we hear you fine.
Good, good, good. Right. Is the screen up? Can you see my screen? I've prepared my screen a little bit. As you can see, I've got 3 sections here with the dialog session in the bottom right corner. And I've brought up 2 browser windows here to demonstrate a very typical application, a web application that requires WebSockets, and that's a chat application. On the APL side, I'll start my application, my WebSocket chat server in a separate thread. I then go to my browsers and refresh them just to connect to the server. And to demonstrate, I can say hello, and a message is transmitted. We can see the message was received on the server and it was broadcast to all listening clients. So if we have another user on this end saying, "Hi, Gil," we see the immediate update on the second window here. And if we look at the actual code to serve this, I'm not using the classy approach that Morten presented. I can try. The windows are very small. Let's see. There we go.
That's good.
Right. So what we're looking at here is initializing Conga, starting a server, and if that's successful, I keep track of connected clients, wait for a connection. The interesting bits are when you get an upgrade request from a client to upgrade to the WebSocket protocol. I accept that without questions asked and add the client to my list of clients. On error, I just close it down and remove it from the list of clients. And when I get a text message, I treat it as a JSON string, deserialize it, add a date, timestamp, and serialize it again, send it back to all clients. And that's the loop. So it simplifies broadcasting messages in that way. We can take a look at another example. This is the live tables sample, which if you've been to Swed APL, you'll recognize this is the same samples I demonstrated last year. And if we refresh this one, we've got it connected. I can then demonstrate filling up a table of 100 cells at a rate of 500 per second, which, if you can see there, is iterating through each cell by cell and updating it with a new value. So the throughput, although it is on a local machine, is still relatively high and uncomparable to normal HTTP requests. So by establishing a WebSocket connection, we managed to send a new message every 2 milliseconds. Right. My mini project, since Bjørn gave me this Conga 3 version, is to create a sub-protocol for WebSockets, which essentially is what is it called? The Web Application Messaging Protocol, which allows us to use a separate router for broadcasting messages as well as acting as a remote procedure router. What I've used is a router implemented in Python called Crossbar. And I will just demonstrate what that looks like by starting the, let's see, we'll stop this one and start our stats WAMP server, which in this, if you use a WAMP, the WAMP protocol, all the endpoints become clients. So I'll update this and we can see that the stats update every second. The way it's done is by connecting both the front end here and the application backend to the messaging router, and thereby the backend is also a client, and it sends messages to the router, and the front end is another client that subscribes to messages and therefore gets the message that the backend is sending. And just to, let's see, how should we best demonstrate that? Publish stats is a function that gets triggered in an endless recursive loop. It's publishing a message to on this topic. This topic is also subscribed by the client. So if we look at the client code, we can bring that up in here, I guess. Let's see. This is the bit of interest here in the bottom. We've got a connection to the router and a callback defined which, when it's open a connection to the router, subscribes to this topic and attaches a callback that updates the charts on screen. I don't have an example of when this is used in remote procedure mode, but essentially it's working the same way in that a client can register a procedure to be called, giving it a unique name, a URI, and attaching a callback function to be called when a consumer wants to call that function. Similarly, you can call functions by identifying the unique name of the procedure on a remote machine and pass it the parameters. And that will then trigger the result to be passed back when the remote procedure has completed.
Okay. I think we have about 1 minute left for your information. Oh, could you see the numbers up in the video there? Roger's waving 1 minute at you. But I mean, I think actually it was quite cute, wasn't it? And the graphs are very nice.
Right.
Okay, so half a minute for questions.
There's a queue over there.
There's a queue. How many have you got?
Is Conga 3 supporting HTTP 1.1?
Yeah.
Okay. No more questions for me.
Okay.
Is it supporting 2.0?
Not yet.
The question is, what's the availability of Conga 3? I think we're targeting version 16, more or less. Yeah. But if people want to play with it, there are several people who actually already have copies who would be very happy to, as long as you can accept that we might change the design a little bit based on feedback still.
You should not put it into production because there's a good chance something will change.
Yeah, I mean, we've had very good feedback from Gil, for example, and I think Michael had a play with it as well. And that's been very useful. Thank you very much, both of you.
Kai had another.
And Kai?
I'm sorry, but have you seriously considered to support HTTP 2.0? I hope that the answer is no.
Yeah, I postponed it because there was I think it was 6 or 7 IFCs for HTTP version 2.0, and I was kind of not able to grasp the concept, so it was kind of postponed.
Right, because I think that is the biggest mistake ever made in the HTTP protocol.
What's that?
2.0.
Oh, 2.0. So you're saying we shouldn't?
Yeah.
All right. Well, that's easy.
Yeah. Done.
Thank you. Thanks. Okay.